Hello, everyone. My name is Jeroen de Koning. I'm in i3d.net today, and I'm here with my colleague Martijn.
I'm Martijn Schmidt, VP of Network at i3d.net. I've been here for 11ish years, and I'm in charge of figuring out where we bring our network next and how we connect with the parties locally there.
The reason why we brought Martijn here today is because we get a lot of questions, or we get a lot of talking points with our potential customers and our customers as well, why a backbone makes sense for real-time applications. One of the reasons being is that in the industry, we hear a lot about edge compute or keeping data as local as possible or keeping traffic as local as possible. But then we have our VP of Network here who's built an entire backbone spanning the globe for all of our traffic. So we want to ask him a few questions to elaborate to everyone why a backbone is important even for real-time applications.
Yeah, I would say it's especially for real-time applications because you mentioned as local as possible. And I think there you are having the key point. Yeah. Because when we are talking about real-time communication, it's two humans that are interacting with them or with each other at that moment, right? Yeah. So you can't decentralize that any further than where people are sitting almost next to each other, right? Or in the same city or the same country or whatever. As soon as you want to speak, let's say, in the Netherlands with your friend from Los Angeles, and one of you is going to have to, or both of you are going to have to traverse some distance to stitch the discussion together. Yeah. And that's where private internet backbone comes into play. Where it gives you more control than if you were throwing it over the fence and hoping that it arrives through your upstreams.
Yeah. Can you dive a little bit more on that? Because we're saying for interregional traffic, people have to travel, or the data packets have to travel over the internet or over backbone in order to reach each other. What is the key difference between going over an internet backbone that's owned by a company and that's managed, or throwing it over the fence? What are the key metrics there that might disturb a video call for?
So I think that in general, the internet is optimized for cost, right? Mm-hmm. And you are looking to get the best economic performance out of your traffic. And sometimes that means, for example, if you're talking about Eastern Europe, that if you want to go to the neighboring country, then even though your fiber passes through there, you don't actually break out with a router there. And what you can't handle inside your own borders, you are bringing all the way to, for example, Frankfurt. Sure. And then you are hairpinning back to get to the country that you actually wanted to reach, again, traversing the same path. Yeah. So we call that scenic routing or tromboning, where you are traversing way more distance than you would have needed otherwise. And when you have your own internet backbone as a company, you are able to put more control there and kind of redirect the flow of the internet away from just cost optimized decision making, also into quality optimized decision making. And I think that especially for the segment of customers that we are talking about here, so the real-time communication, that kind of thing can make a big difference in the user experience for the voice call or for the video call.
Yeah. So what you're referring to is the optimization of your routing, essentially. Is that then only for latency to ensure that that's optimized, or is it also to optimize for a potential or de-risk jitter? All these kind of metrics as well.
Yeah, I mean, the more that you rely on some choke points in a way, the more risk you have, right? Like the blast zone becomes larger. Yeah. And as soon as you have your own control and your own adjacencies, right? The i3d.net network, for example, has over 9,000 unique networks adjacent to it. That means that we don't rely on one or two gateways into the internet or even a couple hundred to the internet, but we have more control over how things interact. And it means that if we have a problem on one of those 9,000, it doesn't affect the other 8,000 plus interconnections.
Do these adjacencies mean that if, for example, I'm calling with a friend in Los Angeles again, and we're based in the Netherlands, do these adjacencies mean that if an application is hosted on the i3d.net network and we are calling with that friend in Los Angeles, does that mean that we are able to pick up their data packets sooner and pull them to our private network to make sure that we control that network sooner?
Yeah, so what you're talking about is, I guess, the hot potato versus cold potato routing schemes, where what it refers to, let's say you take a potato that's been roasting in the fire, you put it in your hands. If it's very hot, you want to drop it immediately, get rid of it. And if it's cold, then you can take it with you and bring it on a nice journey or whatever, right?
Yeah.
And the idea of hot potato networking is that the network that is receiving the traffic, it knows the best where to find its own customer. So it can take the traffic in the correct direction. It doesn't have to guess whether it needs to go east or west or north or south. It knows because that's what it's being paid to do. And so what we are doing is something that's called cold potato routing, but we advertise our internet prefixes consistently. So if you are interconnecting with i3d.net in Los Angeles, you will get the same route announcements as if you are connecting with us in, let's say, Bucharest. This means that when the Romanian ISP, let's say, is sending over the traffic to us, and it needs to go to Los Angeles, we will carry it from Bucharest all the way across continents and oceans to bring it to where it needs to be.
Yeah.
Vice versa, we will bring the traffic, out of our network as soon as possible, but as possible is the keyword again, because we bring it to the nearest interconnection with that network. And usually Romanian network, for example, doesn't have a presence in the United States. So it means that we do carry it from Los Angeles across the entire United States, then across the Atlantic Ocean, and then probably, let's say, in London, Amsterdam, or Frankfurt or something, we will have the nearest interconnection. We hand it over and boom. And why that is important, if you look at Romanian ISPs, for example, some of those companies also have subsidiaries in, let's say, Hungary or in Spain or different countries in Europe.
Yeah.
So if we always said, this company is headquartered in Romania, we are bringing the traffic to Romania and handing it off there, we could torpedo the performance for the users in Spain or the users in Hungary because we are passing first in the wrong direction and then comboning back to where it should have been. So that's the reasoning behind the hot potato routing. We assume that they know the best way to get to that end customer.
Is it then also not just owning that internet backbone or having that internet backbone for you to leverage, but also the combination of the backbone plus the adjacency so you can pull it into your control as soon as possible and then from there direct it all over the world?
Yeah, exactly. It's the combination of things that is what makes the special sauce in a way, right? Because if you only have the adjacencies but not the backbone, well, you can't do the long distance traffic yourself. You still have to end up giving it to one of your upstream providers. Likewise, if you do have the backbone but not the adjacencies, then yeah, you could transport it if it lands on your network, but then...
It needs to land.
Yeah, exactly. If it doesn't, then you are still out of luck. And I think the other component there is also that it's not just what internet exchanges, for example, you connect to, but also who you actually peer with on those internet exchanges, right?
Yeah.
Because if you're just turning up a session to, let's say, that out servers, you're going to miss mostly the important networks that your end users care about.
Not only connecting to it, but what you do with it after connecting.
Yeah, exactly. And even some of the biggest networks in the world do not participate in internet exchanges at all. They have different drivers for their decision making.
Is that cost optimization rather than...
In part, but also in some cases quality, right? They want to de-risk. So with an internet exchange, it's pretty much in many cases a black box. Like you hand over the traffic to the internet exchange, it does some magic in the metro area, brings it to the handoff point of the other ISP. Yeah. But you don't have a direct visibility in whether that other ISP has the correct amount of volume available.
Okay.
Usually they do, but you can only be sure if you have a dedicated port with them, so a private network interconnect.
Yeah. Yeah. So Martijn, we've been talking now about the impact of backbone or the reason for having a backbone for interregional traffic. Let's say I'm talking to a friend, you're in LA, I'm in the Netherlands, what the impact is of that. But how can we translate this to more regional traffic. Let's say I'm living in Vienna in Austria, you're in Slovakia, in Bratislava, or with other friends in Hungary, Romania.
Yeah.
Smaller distance, different ISPs, different countries. How does it work in that situation?
Yeah, so I think that this is like the region Eastern Europe, right, that we're talking about. And so if you are having the Eastern European user base, then traditionally you are seeing what I talked about at the start of the conversation, right? You've got the decision-making optimized for cost and not for performance. So from Romania, you go all the way to Frankfurt if you can't handle the traffic in Romania.
Yeah.
From Hungary, you go all the way to Frankfurt if you can't handle the traffic in Hungary.
Sure.
From Austria, you go all the way to Frankfurt if you can't handle the traffic in Austria. But you don't generally go the opposite direction, right? You don't go upstream.
Yeah.
And it's the same for Ukraine, for example. If you can't handle the traffic in Ukraine, well, you go either to Warsaw, where there is some interconnection with a part of the Ukrainian ISPs, but not all. And otherwise, you go to Frankfurt all the way. And what a backbone allows you to do is to bring the traffic from that wider region, so all the users together into one community.
Yeah.
And so you're really building up that community by transporting the traffic in a way against the normal path, by picking it up from the ISP as soon as you can and then taking it in the opposite direction than it would have naturally flowed.
Yeah. So even though the distances between these cities, Vienna, Frankfurt, 800.
Yeah, I mean, it's always a little bit, right? And you have to keep in mind that you're going there bidirectionally, right? So first you have to go Vienna to Frankfurt. Let's say it's 10 milliseconds. I don't know from the top of my head right now. But then you also need to go back again. So that's also counting. So then effectively you're talking about 20 milliseconds round because you're doing a double round trip in a way.
So let's say we take these cities, right? Vienna, Bratislava, and Budapest in Hungary.
Mm-hmm.
If you would serve your real-time application that runs on compute servers or services somewhere in the world, if you say, okay, well, I want to have that as close as possible to the end users, so I do a few compute resources in Vienna, a few compute resources in Bratislava, and a few compute resources in Budapest. That is situation A. Situation B is I put all of the compute resources in a single location within the region, let's say Bucharest, for example. What is the main difference between the two options? And would even putting all compute resources in one location with a backbone have benefits over putting the compute resources as close to the user as possible, because you still have to connect them together, right?
Yeah, I think if you are going to the full decentralization option, right, if that provider which you're using for that doesn't have its own backbone to stitch all these resources together, then what you're going to get is that the performance will be very good for one country or one ISP or maybe for a couple of ISPs, but it won't be perfect for everybody in that area.
Yeah.
And what we see is that generally, let's say 80% of the people are coming from nearby that location where the computer's sitting.
Yeah.
And 20% is coming from farther away. Can be one hop away or can be literally the other side of the world.
Yeah.
And I think that by having the resources completely decentralized and not stitching it together, there's no interconnection between all these different hubs, then you will have the problem that you can't get the right performance when you're crossing borders, right? And so by choosing a provider that does have a backbone between all the different cities, even if there's not compute in all these different cities because the demand is maybe not there yet, you still create the opportunity to put a compute there in the future, and when the commercial conditions are right. And at the same time, you already centralize your community a little bit, right? So you really enable that cross-border communication. If we're looking at, for example, what's happening in Ukraine now, if people have family that is living abroad as a result of the invasion there, you are really able to bring the traffic or really able to bring people together with their family again by connecting it in a local manner. Yeah. So crossing borders is important to any kind of communication or interactive type of application.
Yes. Martijn, thanks for joining today. We discussed that regional, interregional dependencies in a backbone and how it can impact.
Yeah.
Thanks for joining.
Thanks for having me, Jeroen.
Yeah.
And we'll see you in the next time. Goodbye.
See you. Bye-bye.